If you've watched part 1 of this video, then we're ready to do some more practice finding inverse matrices. Let's find A inverse for a 3 by 3 matrix. Let's say our matrix A looks like this. So the general procedure for finding the inverse matrix for 3 by 3 or 4 by 4 or larger matrices is to write down your matrix A, draw a vertical bar, and beside it write down the identity matrix of the same size. The plan is to do some row operations here, and as the left side turns into the identity matrix, the right side will become our inverse matrix. So very first thing we're going to do, copy out our matrix A, and beside it, copy out the identity matrix of the same size. So we need the 3 by 3 identity matrix there. Now, to get the identity matrix on the left, the first thing we need is a 1 in the upper left corner. So there are a couple things we could do. We could divide row 1 through by 2, but probably easier is to remember that we can switch any two rows. So let's switch row 1 and row 2. So that whole second row, including the right side of it, is going to come up to the top, and our original first row is going to move down now into the second row. And as we do that, the third row won't be changing. So switching two rows really comes in handy if one of the other rows contains a 1 in the position that we're looking for. So we've now got a 1 in our upper left-hand corner, and we are now going to get zeros in the rest of that column. So when we're trying to get zeros, it's handy to think about working with the row that we're on, so row 2, and then we're going plus or minus a multiple of our pivot row. And the pivot row is just the row that contains that circled 1 there. So in this case, to get rid of this 2 that's sitting right here, we could go the row that it's on, row 2, minus 2 times our pivot row. So that will be the perfect multiple to eliminate the 2. And to get rid of this 1, well, it's in row 3, and because it's a 1, we're going to go row 3 minus 1 times our pivot row. So just row 3 minus row 1. And let's do those two operations simultaneously. So we'll just copy out our top row here, and then we're going to do row 2 minus 2 times row 1. So that will give us 0, 2, negative 2, 1, negative 2, and 0, as long as we do row 2 minus 2 row 1 all the way across there. Now in our bottom row, to eliminate the 1, remember we're going to go row 3 minus row 1. So we'll get 0, 0, 1, and then 0, minus 1, 1. Okay, so at this point, everything's looking good. We've dealt with our whole first column there. We've got our 1 and we got zeros everywhere else. So we're now going to look at our 1 that we were working with in this previous step, and let's move down and to the right. So this 2 here, our job is now to make it a 1. So to do that, let's take row 2 divided by 2. And we'll get 0, 1, negative 1. And continuing to divide by 2, we'll get a half, minus 1, and 0. And we can recopy our other 2 rows because they're not changing in this step. Okay, so we can circle that 1. That's the first half of a 2-step procedure. You get a 1 in the position where you want it, and then you use that 1 to get zeros in the rest of that column. Now in this case we're lucky because we've actually got zeros in the other positions in the second column. So that second column all looks great now. And that means that we can move down and to the right. We're going to move down to this bottom right-hand corner here. Our goal would be to make this a 1. Happily, it's already a 1, so we can circle it. That's going to be our next pivot. So our pivot row is now row 3, and we can use that to get zeros in the rest of the third column. So let's see if we can get rid of the 2 and the -1 here. So to get rid of the 2, we're going to write down the row that we're on is row 1. And to eliminate a 2, we're going to need to go -2 times our pivot row, the row where that circled 1 is sitting. So we'll do row 1 -2 times row 3. To get rid of this -1 in the second row, we'll have to go row 2 and now plus 1 times our pivot row. Our pivot row is row 3, just where that circled 1 is. And row 3 can stay the same. So let's go through and figure out what we're going to get. From row 1 -2 row 3, we're going to get 1, 0, and 0. And over on the right side, 0. If we're careful about our signs here, we're getting 1 plus 2 is 3. And then we got a -2 over here. Moving down into our second row, we're going to do row 2 plus row 3. So we'll get 0, 1, 0. Half, -2 and 1. And then our bottom row will stay the same. So after a few steps, we've now finally got the identity matrix on the left. So we've gone through this procedure that started with our matrix A, and it gradually undid the matrix A to get us down to the identity matrix. And as that happened, on the right side, we've built the matrix that is going to undo A. In other words, we've found A inverse. So A inverse is equal to just this matrix we've got on the right side. I'll just copy it out again for clarity. Okay, let's try another example of finding A inverse. So same procedure as before, we're going to write out our matrix A. And before we do any operations on this matrix, we're going to write out the identity matrix right beside it, and we're going to try to do some row operations here to produce the identity matrix on the left. So first thing we need is a 1 in our upper left hand corner. Let's do row 1 divided by 4. So we'll get 1, 0, 3, 1/4, 0, 0. And we can recopy our other 2 rows. Okay, so we've now got this pivot in our first column here. We've got that nice 1. We could use that 1 to eliminate any other numbers in that column, but we've actually already got zeros all the way down there. So that first column looks great. That's all done. And we're going to move down into the right. And we're now going to try to get a 1 in this position. So let's do row 2 divided by 2. Just divide by 2 all the way through there. And our other rows will stay the same in this step. Okay, so we'll circle that 1. We can refer to that 1 as our pivot, and we can now use this pivot to get zeros in all the other positions in that column. So really what we're going to have to deal with here is the 3 sitting underneath that 1. So to eliminate the 3, we're going to do the row that we're on, that's row 3, plus or minus an appropriate number times our pivot row. So to get rid of a 3, let's go minus 3 times our pivot row. All right, so that's going to give us 0, 0, 0. And over on the right side, continuing to do row 3 minus 3 row 2, got 0, minus 3 halves, and 1. Okay, now we could recopy our top 2 rows if we like here, but just a comment before we do that. Notice that we've got a 0 row now on the left, meaning we've got a row that consists entirely of zeros on the left side of the matrix. As soon as this happens, this is an indication that we cannot make the identity matrix on the left. We cannot make the matrix I, and what that is telling us is that A inverse does not exist. We saw earlier when we talked about inverse matrices that not every square matrix has an inverse. So the way we're going to recognize that our matrix does not have an inverse is when we run into a 0 row like this. So as soon as we see that, the problem stops and we say A inverse does not exist. Okay, let's try one more example of finding the inverse matrix, again for a 3 by 3 matrix. The usual procedure will be to write down our matrix and beside it to write down the identity matrix of the same size. And we'll do some row operations here to try to get the identity matrix on the left. Well, we've already got a 1 in our upper left-hand corner, so we've got our pivot, and we can now use that pivot to get zeros in the rest of that first column. So if we want to get rid of this 1 here, we're going to go the row that we're on plus or minus a multiple of our pivot row. So let's do row 2 minus row 1. And we'll get 0, 0, 2. And we'll have negative 1, 1, 0, as long as we do row 2 minus row 1 all the way across here. So let's recopy our other 2 rows. Those ones won't be changing here. So we've now dealt with the first column. And if we're just really focused on getting the identity matrix here, we might think about going down and to the right and trying to get another 1. But if we think back to our last example, remember that as soon as you get a 0 row on the left-hand side, the problem is going to stop. So a better thing to do here would be to notice that if we actually did row 3 minus 2 row 2, that would result in a 0 row. Okay, that's happening just because row 3 is a multiple of row 2. So as soon as we see the potential to get a 0 row, we should do that, and we'll find that, in fact, A inverse does not exist for this problem. So doing row 3 minus 2 row 2 is going to give us a row of zeros on the left-hand side. At this point, it doesn't matter what the top 2 rows here are. It doesn't matter what this right side looks like. We've got a 0 row on the left. That tells us that we cannot make the identity matrix on the left side. And we can conclude that A inverse does not exist. So for any matrix A that we start with, we will either be able to create the identity matrix on the left, in which case we've got an inverse matrix, or we will be able to create a 0 row on the left, which tells us that A inverse does not exist.